Okay, Algebra 2, we're going to take a look at our 9.5b samples. Here's our directions. For each problem, determine if there are 0, 1, or 2 triangles that could exist with the given information. You do not need to solve the triangle. Show all your work to support the answer given. Okay, so unlike in your homework where once you found out if there were 0, 1, or 2 triangles, if there were any triangles, you found out all of the missing measurements. You solved the triangle. Well, for our samples and for our quiz, we will stop at the point that we've determined if there is 0, 1, or 2 triangles. We actually will not continue solving the triangle at that point. So I'll make this a little bit shorter. All right, sample 1. We're given an SSA triangle here to see how many triangles are possible. So A is 104 degrees, which I've drawn here. It's obtuse, so making it a little wider than 90 degrees. And A is 25, B is 16. So let's see how many triangles are possible here. Well, to figure that out, we're going to set about finding if there is an angle B that we can actually place here, given these dimensions. So we're going to use our law of sines. So sine of A over A, sine of 104 degrees over 25, is equal to sine of B over B, which is sine of B over 16. And notice I'm using the notation B1 because it's possible there would be a B2, just to distinguish in case we can find another measurement that works. All right, so using cross products, we'll have 25 times the sine of B1 equals 16 times the sine of 104 degrees. And dividing both sides by 25, we'll have sine of B1 is equal to 16 times the sine of 104 degrees divided by 25. All right, so my calculator, I'll work that out, and I'll have sine of B1 is equal to 0.62098, blah, 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 blah. And we'll find sine inverse so we can solve for our B1. Sine inverse of 0.62098 is B1. That means that we can find an angle, because in our calculator it will return B1 is equal to 38.38841, da, 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 da. And so we'll round that off to B1 is 38.89 degrees approximately. So yeah, one triangle is possible. We're not going to continue solving the triangle. There are some other unknown measurements in that triangle that we are not asked to find at this point. Let's see if there's a second triangle possible. So the supplement to this angle B1, 38.89, is 180 minus 38.89, which gives us a second possible angle, B2, of 141.11 degrees. Remember, these two angles will return the same sine value if we set about figuring out what the sine values are for these two angles. So we're finding out another angle who has this same sine value, this sine value that we got here. So we're checking to see if a second triangle is possible. So we found out that angle B2 has the same sine value as angle B1, and so we're going to ask the question, if we take angle A, 104 degrees that was given to us, plus this new possible second angle, 141.11, is that less than 180 degrees? Because all three of those angles in the triangle must add 180 degrees if a second triangle is possible. Well, when we add the angle A and our angle B2 together, we find out that we are not less than 180 degrees. 245.11 is already beyond 180 degrees. There's absolutely no room for a third angle, let alone the two angles in the triangle, because the three of them have to add 180. So a second triangle is not possible. Note, angles A and B2 add to more than 180 degrees, leaving no room for angle C2 in the triangle. So a second triangle is not possible. So that's all our work that will lead to stating one triangle can be made with the given two sides and an angle. There's our one triangle possibility here, and over here we've just shown a second triangle is not possible. Sample 2. How about these measurements? Again, it's another side-side angle triangle, so we know that it is possible there could be 0, 1, or 2 triangles given these dimensions. So we draw the possible triangle, and then we set about finding our unknown angle B1. So we're going to do sine of A over A, sine of 60 over 4, is equal to sine of B over 14. We don't know our B. I'm going to label it B1 in case there's two possible angles for B. All right, I'll use cross products now to start solving for my possible angle B1. 4 times sine of B is equal to 14 times sine of 60. Divide both sides by 4. Throw all of that into your calculator. And your calculator will tell you the sine of B1 is 3.031. And at this point, you're going to know there is no angle possible for our angle B1, because sine ranges between -1 and 1. Any values, any sine values that you propose that are less than -1 or greater than 1 are impossible. So we know what's going to happen when we figure out the answer to what is that b. We'll try sine inverse here. Sine inverse of 3.031 equals b1. And when we plug that into our calculator, there's an error message. There is no angle possible. So we can't even find an angle measurement for b. No triangle can be made with the given two sides and angle. So we're done with this problem once we've determined no triangles are possible. Sample 3 will have us practice with what does it look like when we find that there are two triangles possible. So again, we have side angle for this triangle here. So we know there are 0, 1, or 2 triangles possible. So let's see if we can find, first of all, an angle measurement for C, and we're going to call that C1. So we're going to do sine of B over B, that's sine of 70 over 85, is equal to sine of C over C, that's sine of C1 over 88. Cross products will give us 85 times sine of C1 equals 88 times the sine of 70 degrees. Dividing both sides by 85 gives us sine of C1 is equal to 88 times the sine of 70 over 85. Using our calculator here, we're going to find out the sine of our angle C1 is 0.97285. That's between -1 and 1. So we're going to get a value for our C1. We'll go ahead and rewrite this as sine inverse 0.97285 equals C1. And when we plug the sine inverse of this number into our calculator, we'll find out that angle C1 is 76.6203, so round that off to C1 is equal to 76.62 degrees. So we know at this point one triangle can be made. Now let's see if a second triangle can be made. Let's find the supplement of angle C1. To find the supplement, it's 180 minus 76.62, because remember supplementary angles are angles that add to 180. So here we're going to go ahead and check. Could a second triangle be made? So remember that these two angles, our C1 and our C2, would have the same sine value. That's why it's possible there is another angle that works. Okay, so we're going to check and see, could this C2 angle here also be 103.38 degrees? Could we get all of the other measurements to work out in this triangle? Well, let's see what happens when we add the known angle, 70 degrees, plus our proposed angle, C2, 103.38 degrees. Is that less than 180 degrees? And when we add them up, sure enough, 173.3 is less than 180 degrees, leaving room for a third angle. We could find a small angle C here. It wouldn't be a very large angle, 173.38 plus a little bit more than 6 degrees would be all that's left for that angle C, but enough that there would be room for our angle A, our angle B, and our angle C. So yeah, a second triangle can be made if C2 is 103.38 degrees. We are not asked to find out the missing angle measurement that we don't know. We're not asked to figure out our angle A2, and we're also not asked to figure out our side length A. That would be solving the triangle, and all we were asked to do was determine, can you make 0, 1, or 2 triangles? We have enough information here to know that one triangle can be made, a second triangle can be made, so yes, 2 triangles can be made, and we could find all the missing angle measurements in both of them and solve both triangles, but we were not asked to do so, so we won't. All right, it's time for you to move on to the quiz for this lesson, and I will see you next time.